Thanks for having me today, and I'm sorry I can't be there in person. COVID has hit my household, so I'm stuck at home. Hope you all have enjoy this talk anyway. This presentation starts with a story really about me. So I'll go through get this part quickly, but I'm not a scientist. I'm just a person, and I didn't work at NASA when I decided to make a website called Apollo in Real Time. This was really a passion project of something that I wanted to make something cool. I wanted to put it out there in the world because I was interested in it, and it took me a very long time. And I started with Apollo 17, which took 6 years to make, and then I released it out to the world. And I couldn't believe it, but people from around the world thought it was great. I thought I was making it really for a tiny community of people. Um, and I never expected anybody in the actual space industry to be interested in it. Because like I said, I was just trying to make something fun. And then this guy called me. Noah Petro called and basically said, this is a really awesome tool that you've made. And I said, what do you mean tool? Well, first of all, this is awesome. You're from NASA. Nobody from NASA has ever contacted me before. And Noah basically explained that putting all this data together the way that I had in Apollo in Real Time was valuable, and that context is very important. And this word context has come to mean a lot in the work that I've been doing. And Noah invited me to come down and give a talk at Goddard Space Flight Center, which I couldn't believe. I thought this is a perfect cherry on top of all this work. I'd been working for 7 years at this point on Apollo 17, and I'd be able to tell my grandkids that I got to go to NASA at the end of all that. And this isn't actually a picture of me giving that talk, and I didn't know it, but at this moment, my life was changing, and it was changing primarily because this guy was in the audience. So this is Jake Bleacher. And Jake Bleacher was the field lead of a survey node called RISE, which was the first RISE. And Jake, after the talk, pulled me aside and explained that they were having an issue with putting their data in context. So they had all this field data that they were collecting as part of RISE, and they thought maybe the way that I had put together Apollo 17 data could be the thing that could tie it all together. And would I come with them to one of their field deployments for RISE? And I was having an out-of-body experience, frankly, when I was being offered to come and actually participate in a NASA operation. And I did. So I arrived, Zach spoke a little bit about Kilbourne Hole. So here's a picture of Kilbourne Hole. And here's a very unflattering picture of me in my brand new field gear standing there. If there was a thought bubble above my head, it would be, there's probably some mistake here, but I don't know why I'm here, but this is great. So I worked really hard on trying to understand what was even happening there, trying to understand all this data that was there. And then when I got back home, I thought I would try to do something with it. So I pieced together this prototype, which is basically how can I tie together all the data that we saw, or all the data that at least lends itself to being tied together. So here we have geospatial data, we have video data. You can't hear them, but there's crew conversations. And then we had XRF data that was being gathered at various points, and they were placing waypoints in the GPS when they gathered that. So I put some of the XRF data in context here in this prototype. And it only took me about a week to make this. And I sent it back to Jake and I said, hey, is this the kind of thing that you had in mind when you thought about putting stuff in context? And they really liked it. So they put it on the hyperwall at AGU and gave a talk about it. And I couldn't believe that what I had done was, making the mark. It was actually something that was providing value. And I, for the first time, really allowed myself to feel like maybe I could contribute something. But to go back to the field for a minute, I met lots of people that happened at RISE. And I'm not talking about Jack Schmidt in the foreground there, or Jose Hurtado, who I've gotten to know quite well. But this guy in the background is another key part of the story. This is Paul Niles from Johnson Space Center. And one morning at breakfast, Paul Niles was asking what I was doing and what I did there. And I was basically telling him I didn't belong, but I was trying to help out with data stuff. And he thought, well, we have this problem at the Neutral Buoyancy Lab at Johnson Space Center. We have exactly the same problem with our data management. And he asked, if I were to send you some data, would you be able to do something with it? Could you see if there's something you could do? And he hadn't seen that prototype or anything yet because I hadn't made it. And here, this is literally the box that he shipped me with Neutral Buoyancy Lab data. And I did the same thing again. I made a prototype. So here it is. And in this case, they had point data of all kinds of the umbilical that is connected to the crew member in the pool. Contains all these metrics of flow rates and oxygen levels and CO2 levels and things. And they also gave me all the joint angles that the remote manipulator arm had. So I made a little 3D model of the Canadarm. Again, this took about 2 or 3 weeks to make. Then they sent another batch of data down, and this time it was for an actual emergency that happened in the MBL. This is an overpress run where pressure was uncontrollably getting higher in the suit, and the crew member was in some amount of danger. And they actually had spent many months trying to piece together what happened for this in this case. And what if we had had a tool like this was kind of the hypothetical question. Would it have helped with that anomaly investigation? The answer was yes. And this led to me being invited to work at NASA, Johnson Space Center, working on an application that we came to call CODA, which is essentially an application that puts data in context. And here's a timeline of the various different versions of CODA that have come to life over the years since that talk back at Goddard. And the current iteration of it looks like this. So lots of different data coming from many different systems within Johnson Space Center, all put into context. This is essentially International Space Station in real time, like Apollo in real time. It's an internal tool that everybody in mission control at JSC uses every day. This is actually footage of an anomaly occurring. A bolt flew out of the crew lock cover when they were opening it. And this is when teams in mission control will snap into action and say, we need to figure out the trajectory of that bolt. We need to know if we're going to come across it again in the next orbit. Does the crew need to abort the EVA? And then we also need to track it long-term for orbital debris. So they need to know the trajectory and the velocity of that piece of material. Now, you probably didn't see it float away, but if you go back and forth enough, and I've actually zoomed in here, see if you can spot it floating away. And if you can't, I actually recorded that same video again with a circle around the object floating away. So that gives you an idea of the amount of granular detail that the people that work in mission control spend lots of time on. And I'm putting video data in context here. This is what this particular anomaly needed. But there's a tremendous amount of telemetry and data coming off the space station, like the joint angles to the remote manipulator. Are one of these data points. There's like everything from solar array angles to voltages to everything else that you'd want to put into context. Here's CODA operating using a field analog. So this is a actual EVA training analog that was happening in 2021, put into context. And in this case, we had GPS data, so we can place that GPS data on a map over time. And then when you go back in time, you'll know where the crew was when they were taking photos, etc. All the same benefits that you get from Apollo in real time. And here's Artemis 1 data in CODA. So Artemis 1, all of the photos as they came down and all the different feeds, including NASA TV, all put into context as a demo. And we intend to do this also. Everybody in mission control expects to have CODA available for Artemis 2 and 3, etc. So we've already started. What's that?
1 minute left.
Oh, got it. So we submitted it for an award and got lots of positive feedback. It won an award at JSC, and then NASA gave it an award. And anyway, it's been recognized as a valuable thing within NASA. And this team has grown around this and other tools called the EVA Mission System Software Team that I'm a member of. And here's an analog. This is actual Artemis training where all of our tools, including CODA, are being used by Flight Director Zeb Scoville here as we learn to actually operate Artemis. So back in the field, this is very quick. There's problems with cameras. Cameras are out of sync a lot. So I spent a lot of time synchronizing cameras so that we could get all this data together. And this culminated last year with the EVAs that Zach mentioned. And it was very personally satisfying to put the RISE EVAs into CODA. So we have 8 EVAs at 24 stations, all the data from those EVAs in context in this tool for RISE 2. With that, I'll leave that as the end of our presentation. But thank you very much for your time today. And it's been a real pleasure working with RISE and Survey. And thank you for changing my life.